Hello everyone and welcome to our new section which is called hashing. With this lecture, we are starting to learn a brand new topic which is called hashing. In this section, you will get a deep knowledge about hashing, which includes hash functions, collision resolution techniques, hash tables, practical use of hashing. And we are going to implement hashing in practice. So in the first lecture, let's identify what's hashing. So by definition, hashing is a method of sorting and indexing data. The idea behind hashing is to allow large amounts of data to be indexed using keys commonly created by formulas. So let's make this definition clear by using a real-life example. So let's assume we have 3 strings and we want to store them in an efficient data structure. So if we want to store them using hashing, the first step over here is we are changing these strings into a number using some magic function over here. So we are going to pass these strings to this magic function over here, and by using this magic function we are going to get some numbers out of this magic function. So our first string is apple. So if I pass apple to magic function over here, it's going to return in this case 18. So it's doing some operation over here and returning 18 over here. So the next word is applications. So if I pass application to this magic function over here, in this case it's going to do some operations and it's going to return 20. So these numbers are random numbers that I'm taking because based on the magic function, these numbers might differ. Now the last word is appmillers. So if I pass appmillers to this magic function over here, it's returning 22. So this is the first step when we are creating a data structure using hashing. So we have converted these strings into numbers using magic function over here. So you might be interested, how do we convert them? And what is the magic function over here and how it works? So we will discuss everything in detail in our upcoming lecture. Now you just need to know that this function is responsible for converting these strings into number by using some formulas inside this function over here. Now the next step is we have to store these numbers into some data structure. So we are going to create an array in which, for example, for this case, we will have 23 cells in our array over here. Now the next step is by using these numbers that we get from magic function, we are going to insert these strings to these indexes over here. So for apple, we have got 18, so this means that apple will be inserted at the index of 18 over here. So for application, we have got 20, so this means that application will be inserted at the index of 20. And for appmillers, we have got 22, so appmillers word will be inserted at the index of 22. So as you can see, by using magic function, we have converted these strings to the numbers and we have used these numbers as an index in the array over here, and we have inserted these strings over here. So if we quickly recap what we have done over here, so we have taken these 3 strings over here and by using magic function, we have converted them to the numbers, and by using these numbers, we have inserted them to array structure over here. So with this, we have inserted these strings into this array using hashing successfully. Now the question is, if we want to read the data from this array over here, how we will access these strings over here? So one more time, for example, if you want to access the apple in this array over here, we are going to pass apple to this magic function and it's going to return 18. So by using index of 18, we can access this cell apple over here. So this means that whenever we are passing a word to the magic function, it's always returning the same number. So when we are inserting, we are doing the same operation, and when we are accessing the same string, we are going to use the same operation by getting the index of mentioned string from the magic function over here. So with this, we can easily identify whether this string in this array or not. Now you might be interested, why do we need hashing? So let's say we want to develop an application in which search operation is used heavily, and we want our application to perform as fast as possible. So in this case, we can use hashing. So hashing performs better than other structures in terms of searching operation. Now let's see search operation in other data structures to understand it very quickly. Now when we are searching for a given value in these data structures, in case of array, the best performance is O log n time complex. Because if the array is sorted, the time complex for searching for a given value in the array will be O log n time complexity. Now similarly, in the tree also, for searching a value, the time complexity will be O log n, because in this case we are either looking in the left child or the right child, so that's why the time complexity is log n. But in case of linked list, we are doing linear search, so that's why the time complexity O n. But when it comes to hashing, In the best case, it takes order of 1 if our hash function performs less collisions. But here you need to take into account that if there are many collisions in the search operation, there might be order of O(n). But at the best performance, it performs O1 time complexity. Now, to achieve the best performance of search operation, the hash function must have less collisions, which will be discussed in our upcoming lectures. So with this, we have come to the end of this lecture. So in this lecture, we have discussed the logic behind the hashing and why we need hashing. Now in the next lecture, we will learn hashing in depth. So see you in the next lecture.